Hello everyone, my name is Taren and I studied mathematics at Cambridge. Today I'm going to show you how to think like an Oxbridge academic. So how do you answer a university level problem? One way to do this is using the TIPS technique, which is tools, information, proposal and state. And I'll go through a question now. So the question I have is, Alice and Bob want to play a game of snakes and ladders. To see who goes first, they roll a fair six-sided dice. They each take it in turns to roll the dice and decide that the person who rolls a 6 first will get to go first in the game. If Alice is first to roll the dice, what is the probability that she gets to go first in the game of snakes and ladders? So the way I approach this problem, considering it's much wordier, is to consider the necessary information in the question. Here we can think about, six-sided dice is relevant, Alice rolling first, and we effectively want the probability of her rolling a 6 before Bob rolls a 6. So the tools here would be a probability tree. That would be useful because then we can draw all the possible outcomes and consider if Alice rolls a 6 on her first roll or on her second roll, etc. So here's a probability tree that I would draw out, and I can see that on Alice's first roll, the green represents the probability of her rolling a 6 on her first go. But if she doesn't roll a 6, then the only way for her to get a 6 again on, say, for example, a second roll or third roll, is if Bob doesn't roll a 6. So I need to enforce the fact that Bob doesn't roll a 6 and then consider if Alex rolls a 6 or doesn't effectively. And you can see this in an iterative process here. And we have that the probabilities that we're interested in are all the probabilities that are in green, because these are the probabilities where Alice goes first in the game and rolls a 6, either on her first turn, her second turn, her third turn. So therefore, we can state, then explain, I could say that, the roots on the tree that are relevant to us for us to consider. Now we can consider our new objective, and we want the sum of these branches because that's a total probability. And so we can iterate the TIPS technique again here and say, well, the information we have our successful outcomes, and so I can work out the sum. So the sum is here, and a tool that would be useful for this is a sum to infinity of a geometric progression, because we can see we have a common ratio of 25/36. So I can remember the formula here. The sum to infinity of a geometric progression is a over 1 minus r. And so I can substitute that in, where a is 1/6 and r is 25/36. And I get this. And if we evaluate this, we get 6/11. So hence, Alice has a probability of 6/11 of rolling a 6 before Bob, which means she is slightly more likely to roll a 6 first. I've just shown you how to answer an Oxbridge mathematics question using the TIPS technique, and you can see where I use tools, information, proposal, and state. My name is Taren, and I've just shown you how to think like an Oxbridge